Hello, everybody. My name is Shek, and today I'm going to present you the work titled The Role of Groups in a User Migration Across Blockchain-Based Online Social Media, a study that was conducted at the Connect Lab of the Department of Computer Science at the University of Milan. Let's start by defining what we mean with user migration. We are defining user migration as the act of users leaving a social media platform for another one. This could be caused by issues such as misinformation or privacy-related issues, or by positive factors or reasons like the presence of new services or features that are not available in the original platform. This is a phenomenon that is widespread and can be observed across main traditional online social media platforms, but also on blockchain-based online social media, which are a new paradigm where we have blockchain technology for storage and validation, as well as the presence of cryptocurrency systems that enable the presence of rewards and trade markets. In this scenario, user migration is strongly linked to hard forks events in which we have the supporting blockchain that is split, and we have the original chain or the fork chain, and users can select one of the available options. And while this is a widespread phenomenon, there is still limited work on this topic. And in particular, there is a limited understanding from a network-based standpoint. There are two key aspects that should be investigated. Number one, the peer influence, the idea that groups or densely connected regions of a social network can exert pressure on the choice of their members. Second, there are no studies focusing on different reasons. So the key thing here is that in Boston, we have also economical interactions that lead to different group formation. And so our research questions are the following, right? What is the role played by groups during user migration and fork events? Are there differences in the network structure of groups of users who stay or leave for a new platform? And finally, are there differences when we consider social and economical interactions? So we define first a methodology for modeling user migration. In this work, we are using a network-based approach to construct. We first construct a weighted multi-layer network. Multi-layer because we can model different types of actions, for example, social and economical, and weights are used to keep track of repeated interactions. By relying on this interaction data, we can construct and update an evolving graph till the time of the network split or fork event. Then, by looking at the activity after the time of the network split or the fork event, we can define the migration decision or status of each user. In this case, in this scenario, we can find that a user is a migrant, so it's active on the new platform, or it could be that the user is a resident, so it was only active on the original chain, or the user could become inactive. So it will mean that the user is not active on either of the platforms. And our main goal is to highlight the role of groups during the migration process. And in order to identify groups in the network structure, we rely on community detection algorithms. We are using multi-layer infomap to find non-overlapping communities, both on the social and monetary layers. The method still considers the information from the other layers in the multi-layer infomap, but we have a definition of communities separated for each layer. And the communities obtained are then analyzed through their features, like the number of migrant, resident, or inactive users. Or we can also look at the network structure. In particular, we are focused on density and entropy, density, as we can see how densely, how tightly connected are certain groups. And entropy gives us an idea of how unbalanced are the labels, so the migration status in different parts of the network. Then we construct the community graphs that are necessary to perform our analysis. In these graphs, the nodes are communities. As you can see here, community 1 becomes a node, and the community 2 is another node. And the idea is that we have a link between different communities if there is at least a link across the communities, connecting members of different communities. And the weights are used to keep track of how frequent are these across community links. And what is the advantage of this kind of visualization? Well, community graphs allows us to study both the social and monetary layer through a visual analysis. And in particular, we can show the community features as a function of the migration status. So as a case study, we are looking at Steemit and Hive, two social media platforms that are blockchain-based online social media platforms. And in this case, we have that the hard fork around the Steemit blockchain generated the Hive blockchain. Thus, we have a detailed information of all the interaction before and after the fork event that happened on March 20 of the 2020. We have therefore the same usernames of both blockchains, allowing us to describe user migration behavior for all the users. The time period covered by our dataset consists of almost 4 years of data prior to the fork event, and we are looking at the migration decision using the rest of the dataset after the fork event up to January 2021. And we are focusing on a subset of social and monetary interactions, and we are looking at almost over 1 billion actions on the Steem blockchain and around 200 million actions on the Hive blockchain. We first apply the methodology proposed on the data and construct a multi-layer network. And the key aspect we first focus on is that if there are any differences between the layers and the impact of user migration. And as you can see here from the table, we have that we have a comparable number of nodes active on both layers, and there are more social actions than monetary actions. We can see from this row that there are a lot of nodes that went inactive, but in particular, we have differences between the number of resident and migrant nodes on the two layers. As you can see, we have that on the social layer, we have a majority of resident layers, nodes, which are users that do not live, whereas on the monetary layer, there is a higher presence of migrant nodes, so there is a higher impact of migration. So this is already a key takeaway, the user migration that differently impacts social and monetary layers. First, we conduct an analysis of the community graphs by focusing on the connectivity among the communities as a function of their migration status. Here, we rely on color and size to show this relationship. In particular, colors are used to represent the fraction of resident or migrant nodes, and size determines the number of nodes involved in the community. If we mainly focus on the connectivity, we can see in particular on the monetary community graph that residents tend to be in the central part, more interconnected part, whereas migrant majority-based communities tend to be more marginal on the sides of the graph, like you can see here and here. Therefore, we can start by saying that marginal groups are indeed more likely to leave the platforms. Then we analyze network structure these communities as a function of the immigration labels. Gray, we are looking at whether there are differences in the network structures for groups of users that stay and users that leave. And we rely on colors for resident and migrant percentages, while we are looking at sides, using sides to highlight density. Higher sides, higher density. Bigger nodes here and this part are linked to the presence of resident nodes, which allows us to say that when we are looking at interactions, monetary interactions, the more densely connected groups are more likely to stay. We then focus on entropy, which is a measure that you can use to see how much a community is unbalanced towards a specific category. Again, relying on the groups we have defined, we can see if they have low entropy, which means we have homogeneous labels, or if there is an high levels of entropy, so different labels. Particularly here, we can see the social and monetary community graph, but we cannot observe some particular characteristic of difference. And so we say that the entropy does not help to characterize the two groups. Finally, we follow up with a quantitative analysis. For each community, we consider the number of inactive, resident, and migrant users, alongside the community features that are related to network structure, so density and entropy. And we look at the correlation between these features, focusing on density and entropy with respect to the other features. And we can see that for the social communities, density has a slightly negative value with the number of resident and inactive users. And there is no correlation with the number of migrant users. While there is, for entropy, we can see that there is emerges a significant positive correlation with the volume of migrant users. Instead, for the monetary layer, we can, and the communities, we can observe that density has a very interesting high correlation with the number of residents, while we find negative correlation of entropy with the presence of resident nodes. Overall, the key takeaway here is that the quantitative analysis is a confirmation that group density can characterize user migration behavior, and that network structure should be considered in these kind of studies. So we have investigated the impact of groups, so entropy and density, in the user's decision-making process to stay or leave a platform. Our findings highlight that the groups play a role in user migration, as we have seen that users in marginal groups are likely to leave, and the users in densely connected groups are instead more likely to stay. And we found differences that are based on the type of interaction considered. Our future works include working with different network structure measures and other community detection approaches, as well as applying the methodology on other user migration scenarios. And with that, that's all. Thank you for your attention.